Hey guys, Tyler from TieSpeed here, and welcome back to another episode on the TieSpeed YouTube channel. I'm excited for today's project. We've received back that S62 engine for machining, and I'm going to be walking you through the process of the assembly of the bottom end, as well as the tools and supplies needed to perform a job like this. I'm pretty excited to walk you through the process, so let's get started. Before we get cracked into the fun part here, I'm going to take a few minutes to walk you through some of the supplies and tools that you're going to need at home to perform a project like this. So let's get started on that. First things first, I'm not a really big fan of gloves, but sometimes we are handling some caustic chemicals, and I do suggest that you guys keep something on hand, especially when things get messy. Keep some contamination from your fingers and stuff out of the way. Obviously a can of quality brake clean, probably a few. Clean and prep the block surface itself, all the different parts you'll be putting on to decontaminate that, so make sure you have a few cans of these handy. Separately, I've got some blue and red Loctite here, depending on what the torque specification is or the part that we're assembling. This is good to have on hand. And we also use Liqui-Moly LM48 assembly paste. This is a really good paste I've found over the years. It's got a good balance between basically lubricity and slipperiness. You're all familiar with this red Ultra Slick. This is kind of a really thick, heavy assembly lubricant. I usually put this on the camshafts itself. It's actually something that we still will probably do today. That's a good thing to have as well. Last but not least, I have a quality paint marker here, TieSpeed Signature Orange. I like to mark all the fasteners, especially in the bottom end, after they've received their final torque sequence, and that way I can ensure that I've done all of the proper torquing on the very most important fasteners on the bottom of this block. Last but not least, we've kept quite a few pieces left here of plastic gauge. This you've probably seen in other engine building videos before. This is a visual tool to measure clearances between crankshaft main and connecting rod bearings, as well as a few other surfaces. So make sure that you invest in a couple of good strips of this. You can get this at any local auto parts store. Definitely good to have with you on a project like this so that you can check bearing clearances of the main and connecting rod bearings. All right, well, separate from having the correct supplies, it's also important to have the right tools for the job, and so let me walk you through a few of those that we're going to be using here today. Let's start off with a few measuring devices. I've got a couple of quality different measuring devices here. I know that you boomers at home are going to be laughing at me for not having a manual caliper gauge. I do have one of those as well. This is just for quick measurements on the fly should we need to use it today. I've also got this very nice high quality digital Mitutoyo external caliper, and this I'll be using to measure later our piston diameters for our piston-to-wall clearance measurement. So good to have one of those. We've got a Goodson machine cylinder bore gauge. This is a handy tool as well. We'll have to get this set up for the appropriate size. We'll again be using this to measure our piston wall clearance as well as journal bearings and other things like that. We've got a fixed dial indicator. This is for measuring travel, such as top dead center. I've also got this handy old school little dial indicator that's got a stand on it as well for measuring top dead center and cylinder protrusion outside of the cylinder wall itself as well, so that's pretty handy to have. Last but not least, once we get to that point and we start doing cam timing, I've got, this is just a generic version. I've got a few of these. This is just a degree wheel, and we'll be mounting that to the crankshaft center bolt and centering that on the crankshaft itself, so that when we start measuring our things like our TDC and our dwell, we'll have one of these handy. You can't really set it with the factory timing indicator, especially when the engine's on a stand like this, so good to have one of those. And last but not least, I've got a variety of torque wrenches. Definitely good to have when putting a motor together. We'll want to be following some of the protocols and the torque guides of the BMW factory assembly manual for this engine. It is an aluminum engine, so it is going to be possible to over torque fasteners. We'll be following various handbooks and manuals included with the aftermarket parts, such as the arrow connecting rods, the CP pistons, and other parts as well, to make sure that we don't damage anything on assembly. And last but not least, one thing that you might not have at home, but you probably should, and this is not something that you need to do if you're doing just like say one motor per year or something like that. I've invested in a total seal piston ring filer. It's electronic. It's also resettable. It's got a dial indicator built into it, so I can set each one to the exact same specification without having to remeasure and recut every time. So this is a very handy device to have. You don't need this at home. They make manual ones. You can get them at Harbor Freight. You can get them online. Easy to have there, but another tool of the trade here that I've used over the years, and it helps speed up the process, especially when you have 3 rings to cut on 8 cylinders. So that's quite a bit of piston ring filing. So this saves me quite a bit of time. So these are just a few of the tools that we have laid out here today that will help with the assembly process at the bottom end of this motor. I think it's probably wise that if you're going to take on something like this with yourself at home, that you have some of these things available to you so that you can ensure success during the installation and assembly of your engine if you're doing it as a DIY project. All right, so in front of us here we've got a very expensive table full of very expensive and nice parts. I'm going to walk you through the various bits that we have here in front of us before we get going on putting them in the engine. Let's start with the most important part, and that is the crankshaft itself. This has been remachined, polished, and rebalanced along with the new rotating assembly parts, including the pistons and rods here. It's an important thing to do when you have a high revving BMW V8 engine, because when you change the weights of the piston and rod combination over the stock cast rods, the stock cast pistons, that rotating assembly weight changes and it can actually throw the balance of the engine off. Everything is balanced together, usually with a flywheel and the harmonic balancer on the front of the motor together. All that stuff is done on a special machine that is used to actually tell the machinist where to take or add or remove weight on the crankshaft itself to make sure that all these new components are spinning around there at 8,000 RPM in a healthy way. So moving on from that, we have our Arrow precision connecting rods. These were sourced from Back Motorsports in Philadelphia, as well as the CP Carrillo pistons themselves. These are forged. They have all new ARP 625 hardware. They've been precision machined for just excellent quality, much stronger than stock. And then last but not least, we have these beautiful forged pistons from CP Carrillo. These are actually dished just about 7 cc's, and what that means is basically the compression has been lowered. For this application specifically, we're going to be adding a supercharger. As a result, the factory S62 compression ratio is around 11:1. These have been reduced down a full point to 10:1 compression. So that'll help take a good bit of boost. It'll help lower the cylinder pressures, and there'll be less chance for detonation, knock, or damage. Moving on down the line here, some of the more important parts that we find in the motor itself is also the bearings, right? That's one of the things we're going to be messing with here today to check clearances on. These were also sourced from Back. These are calico coated Back Motorsport race bearings, and they basically just take a factory high quality BMW original bearing and they put a very special hardened coating on the outside, the exterior of that bearing. This basically just prevents premature wear and tear, helps reduce drag, things like that. We're not going to get super into that today, but also a nice addition to this whole lot of parts here in front of me. So without further ado, let's get going on the process as far as how we're going to be putting all this together and get this into the block itself. All right, so here's where we're at. We've got the block all cleaned and prepped up and ready for assembly. We've gone ahead and flipped it over, and we're going to start with the very first part of installation. Now, it sounds silly, but I've actually left these out before when I started going on bottom end assemblies, and this is actually a piston skirt oiler. So this little part is a little squirting device that actually takes oil from the block galley and sprays it backwards at the bottom of the piston for cooling. This is something that was added in BMWs somewhere in the early 90s. I believe after the S14 engine. Don't quote me exactly on which engine it started on or not, but I do know that it wasn't always around. So this is the very first thing we got to put on the inside of this block. So we're going to go ahead and mount all of these into their individual bores. There's one per cylinder. They're going to get mounted just like so. So we're going to go ahead and put all 8 of those in before we go ahead and lay up the main bearings, the top main bearings, and get ready for measuring the crankshaft and main bearing installation clearance. All right, so we've gone ahead and put the piston squirters in, and now we're going to move on to laying in the upper main bearings. You can usually discern the upper from the lower because upper bearings have an oiling groove in them. As you can see by the one to the right of that, it's got a groove in it, and this one does not. And as a result, that's basically just for keeping oil flow through the bearing there as the crankshaft spins over it. So that's usually how you can discern the difference. We're going to go ahead and lay these in individually, and then we'll be dropping the crankshaft in so we can take our first clearance measurements. One other thing I should note too, that there are grooves, tangs, alignment tangs on each of these bearings, same with the rod bearings, and that specifies which side that they're supposed to be mounted on. We're putting these in with no oil on them at the moment or any sort of assembly lube, and that's because we're going to be measuring the clearance. And in order to do that, we need to do them oil-free. Something unique to this motor that I want to point out to you guys is that this main bearing here comes without a side. We've gone ahead and ordered a couple different sizes of these thrust bearings. And this drops into this groove here on the motor. And the thickness of these determines your thrust on the crankshaft, which is your lateral play, forward and backwards. And there's got to be a little bit of that as well when operating. So that's going to be something that we're going to check to measure here. We're going to use a dial indicator for that shortly. All right, here we are with the main bearing cap. So we're going to be putting the non-groove bearing into the main bearing cap. Again, no lubricant on the forward-facing edge at the moment because we're going to have to measure this with plastic gauge, and if you get oil or any sort of contamination in there, it's going to take away from your measurement. So we're just delicately pressing these into place. Should be pretty secure. You'll know pretty quickly if you have like the wrong size or the wrong part for the application. This is all pretty precision stuff here, and the fitment, you know, should be absolutely excellent. It just comes from experience from me at this point to know what feels wrong or what feels right, but we're also going to be measuring that stuff here shortly. All right, they're all in. All right, so now we're going to lay this crankshaft in place here. Very gently guide it down into the block. Super straight, nice and easy. There we go. Making sure we didn't touch anything here. We should. All fits nicely in there. All right, now we can put the main caps on. We're going to be torquing this up using plastic gauge, and we'll show you that in a second. All right, first things first here with after we've got this crankshaft dropped into the block, we're going to be checking the main bearing clearance. And very simple method, you can do this at home quite easily. We can do it two different ways, but this is the easier way to do it. This is just plastic gauge. Basically, this is just a little bit of like a very small strip of Play-Doh, and we're going to drop this in between the actual crankshaft itself and the upper bearing and cap. And so we're going to lay this very delicately into the bearing journal, and it's basically designed to crush up in a specific amount based on the clearance. So basically for this motor, the fatter that it is, the tighter the clearance, right? The more the crush, or the more that it'll spread out. So what we're looking for on this is about 1.5 to 2 thousandths clearance. 3 is kind of pushing it on a main bearing, in my opinion, especially for BMW motors. I usually see them land somewhere between 1.5 and 2.5 thousandths. So we'll be using this gauge reference on the side here. You can see right now it's, you know, thin as could be, and it's because there is no crush in it. So we're going to be laying these out on the mains. We're going to be putting the main caps on, torquing them to specification, and then after we've done that, we're going to pull them back off one more time and reference each journal to this this plastic gauge wrapper here, and this will tell us if everything's going to be good to go for assembly. Put a little fastener grease here on the top of these. We'll be really even with this, just going nice and easy on the gun here. We're not torquing these at all, we're literally just seating them on the block surface. So like most bottom end fasteners, these are torque to yield, so they have a joining torque, 20 Newton meters, and then a degree rating, which in this case is 100 degrees. So we're using our snap-on tech angle torque wrench, which measures both torque and degree angle. So we're just seating these down. It's very important if you want to get the right measurement to be very careful about applying the force to these caps equally as they seat, so they don't get distorted or incorrectly torque. So we're going right to 20 Newton meters to start. Don't overstretch the bolt. All right, so we've got them torqued to spec. The main bearing caps are on there. And now we're gonna go ahead and release all of the hardware and take these caps back off so we can check on that plastic gauge. All right, the caps are back off and they've been torqued and then removed. And we've got our plastic gauge in here, so now we're using the graph that's included right on the outside of that unit there, and we're going to line that up. We can see our line here. That was the plastic gauge that crushed up here, so take a look. I'm going to lay that up next to it, and I don't know about you guys, but that's looking like 2000s to me. What do you think? Let's move our way back. Let's try this one. Looking about the same. It's kind of hard to see, but you got to just use your judgment here. All right, same here. This one's looking a little bit fatter. Call that like 1.5. Let's call that one 1.5 also. So like we said, 1.5, 2.5, somewhere in there, somewhere in that range is good. There's a little bit of variance here. They are aftermarket coated bearings, so you can see some disparity in that from time to time. Nothing to be concerned about here whatsoever. I think if you really wanted to be perfect, you absolutely could, but the clearances are well within specification, not going to cause any issues. So here's a good one for gloves, huh? Definitely want to have your gloves on for this. I'm just kind of soaking these mains in that LM48 assembly paste. Lather them up real good. Definitely, probably not a thing as too much, but there definitely is a thing as too little. We're going to be spinning this motor over a few times during the course of its assembly, so we don't want to rub it all off before we ever even get a chance to prime or start the engine. Now we're tightening up these supports for the main bearing caps. Kind of unique to the BMW aluminum V8 design here. All right, so our main bearing caps are tightened up after checking all of our measurements. Those were good to go. So let's see, the proof is in the pudding, as they say. We'll try to spin this over by hand and see if we feel any unusual resistance or high spots in the crankshaft clearance. So far, so good. There's 180. And 360. Nice, the resistance feels even all around. Breakaway torque on something like this is going to vary from application to application. It also varies based on what type of assembly lubricant that you've used. For example, if we used that red assembly paste that I showed you earlier in the video in place of the liquid moly 48 paste, the breakaway torque, or the force required to spin this crankshaft over by hand when you start spinning it, is going to be different. So this just kind of becomes a matter of preference and experience, and at this point, you know, based on the type of lubrication we're using, the assembly lubrication that we're using here in this application, I feel that you know, we're pretty good to go here. So no concerns at the moment. We've checked our clearances. We know that all of them are above minimum. None of them are above maximum, and this crankshaft is fully torqued and in place with the block, so it's time to move on to the piston and rod assemblies. All right, so we've got our crankshaft installed, and next on our list is going to be a set of measurements once again, and this time what we're going to be doing is measuring our piston-to-wall clearance. Now, this is something that's been up for debate on our previous video about sleeving and how it doesn't work on aluminum blocks, and they've watched M539 restorations, Alpina blow up in 60 miles. I understand that there are problems and complications when modifying engines such as this. However, if the proper due diligence is taken and the proper techniques are used, I think you can avoid calamity altogether. One of those things that we're going to verify that I know has already been set by the competent machinist at VAC Motorsports in Philadelphia is our piston-to-wall clearance, and we're going to do that using two different measuring devices. The first device is our bore measuring gauge, and now this has been calibrated to the bore itself. There are a few different extensions you can use that vary in width here that can measure the bore. That number we get from our piston spec sheet. So this is included with every set of pistons, and we're basically just going to find the bore diameter as measured here for the piston is 3.7007 inches. So we match that up with our appropriate length tool here. We're going to bring this over to the block. carefully drop this in the gauge, this gauge into the bore here. And I want you to watch up here, and I've already zeroed this, but for the sake of the video, I want you to see we're going to rock this back and forth about midway down the bore. We're finding the zero, all right, so now that we've zeroed out our bore gauge here, we're going to put this aside for a second. And we're going to take one of our beautiful CP Carollo pistons and our Mitutoyo digital high accuracy caliper here, and we're going to zero this in on the piston skirt. So dropping this in dead center on the skirt, about midway down between the third ringland and the bottom of the piston, and trying our best to center this left to right in the pocket of the valves. We are now going to turn this in just a bit until we've encountered some resistance, which looks good to me, 3.696. Going to tighten that up, pull that off the piston, and put that aside. Now, where are we getting all this information from? Well, once again, on our specification sheet, it lists a few different things, and this is going to give us our minimum specification for our piston-to-wall clearance. So, piston-to-cylinder clearance on this application is saying is a minimum of 3.5 thousandths. That's a little bit on the tight side for, I think, a sleeve block. So what we're going to do is we're going to take the zeroed out bore gauge and do a little bit of magic here. We're going to take our caliper here with our piston measurement, and we're going to drop this in here. And let's look together up top. So try to center that. It's not super easy to do, but looking like about, hard to center, about 4 thousandths. Try that one more time. Yeah, about 4 thousandths clearance there. So a little bit over the minimum spec, I'm fine with that, but that is basically how you check your piston and wall clearance. We're going to go ahead and repeat this process 7 more times. I'm not going to bore you with that, but once we're done, assuming there's no issues, we'll move on with the installation of the pistons themselves. Now that we've measured and verified our piston and wall clearance, we're going to move on to the piston and rod assembly. So we've got our components laid out in front of us. Let me walk you through that. We've obviously got our piston itself. We've got a connecting rod. We've got our wrist pin, and we've got our wrist pin clips. So what we're going to do now is we're going to install one of these wrist pin clips into the piston. We're going to take this rod, put it through the bore of that, drop the wrist pin through here, and then we'll be putting on the other outer wrist pin clip. Once that occurs, we've got to do it 8 times. It's a little bit painstaking. Got to be careful with it as well. And we'll be able to move on to setting the ring end gap for all 8 cylinders, which is going to be a little bit time consuming as well. So we're going to walk you through this one here in slow form, and then after that we're going to do a little bit of a time lapse so you can see us put together the rest of the assemblies in quick time. These have bronze bushings here. You can see that orange color. They like to be impregnated with oil. Some guys say that you can let these sit in oil overnight, really let that bronze soak it in. I think if you just give it a liberal coating here, you should be okay. So take that there. Okay, once that's been sunk through there, all right, and that's it. So pistons and rods are assembled. We're going to start by measuring up our ring end gap clearance. As you can see, here is a top ring, our compression ring on a piston, and there is a gap there. Once we install that into the motor, into the correct bore size, that gap will close up as it is inserted into the bore. That is what gives your cylinder, I guess, compression really. So, long story short, it's a pretty involved process, but we're going to make it really simple for you right now, and we've taken a couple of numbers here. And these are the recommendations from the manufacturer of the piston itself. Basically, here we go. We've got our top ring. It's chrome. It's a compression ring. We've got our second ring. This is the oil scraper ring. It's a Napier style, so very hard to see, but you can look that up. Maybe Vin will be able to put in some of that to the video. But there's a hard-cut groove, like a scraper groove on the side of that piston ring there, and that actually scrapes the oil back down off the cylinder wall as the piston travels up and down in the bore. And then we've got these three little rings here, two very small ones, very fragile, very flexible, and our oil retention ring there, which is this corrugated looking piece, and that rides in between the middle of those two pieces and forms your oil control ring. So what we're going to do is we're going to put all these in the bores individually right now, measure them up, and then we're going to come over to our piston ring grinder here, and we're going to appropriately size out the ring end gap on all of these rings for all 8 cylinders. This is a pretty long and tedious process, so I'm going to start with and just show you one singular cylinder. So starting with the compression ring, piston ring number 1, we're going to take this and load it into the block here, carefully compressing that groove down like so, and pushing that down in there. Now we're going to take a spare piston I did not yet assemble and push that down until it is level with the block all around, which it is, and take it back out. Now we're left with the ring in place there, and we've got our feeler gauge with our top one set to 20 thousandths. And as you can see, that feeler gauge does not go into that slot, and that means that we need to trim that down. So this is the correct clearance that we've set for the top ring. It does not go into the groove that is remaining here at the moment. That's because it's uncut at this time. So we're going to take it back out. And we're going to load it into our piston ring filer. So how this works is you lower this guard here. You square this ring up in the guard here, tighten that down, pull the guard back. See, there's a dial indicator here, so we're going to come back. Basically 0 is the grinding stone. Turn that on. Make sure we don't make any contact. We're going to roll that in until we hear some noise. Alright. So there's our 0. So we're going to start with 5 thousandths. So I'm setting that indicator to 5 thou here. You can hear that grinder taking material off that ring end. Alright, let's shut it off. Let's see, so that's 5 thousandths of material removed. Dropping that back in the bore here. Again, taking our piston, loading that down to the appropriate depth, making sure that it's level all around. And then taking our feeler gauge at 20 thousandths. Not quite yet. And back in it goes. Now, we've cut this already, so if we zero it back out again, we can only do it in increments of 5 thou. I think that's the safest thing to do. So we've zeroed it back out. And we'll be able to speed up this process on the remaining cylinders once you see how we get to that number. Back in it goes. Flush with the block. And back to our feeler gauge. Still not quite. So basically you just got to keep repeating this process. The first one kind of sets the precedent for the rest, so we want to be very delicate with what we're doing here. We don't want to rush this and cut away too much material. As they say, measure 3 times, cut once. And with a piston ring like this, you definitely don't want to get that wrong. Okay. Again, loading that in. Repeating the process. Feeler gauge. Ah, perfect. There you go. So that feeler gauge fits perfectly in that groove. It's got a little bit of drag on the way out. Once as I put that in there, fits just barely. I'm pulling on it, it tugs right out. So that's perfectly on the money, 20 thou. The last step here, because we've now cut this ring with a grinder, it's going to be a little rough. You'll see on this side of the setup here we have a polishing disc, different than the grinding disc. So we start that up, and we're just going to gently grind the edge of that down, polish it off. Make sure there's no burrs. Don't want any sharp edges in that bore. So now that this has been cut and polished, this one's ready to go. And again, we started at 0. I've did 3 cuts of about 5 thousandths a piece. That's about 15 thousandths. That means that on the recurring cylinder's top ring, we're going to cut or set the dial indicator to 15 thousandths of cut. And that should get us like right on the money pretty much every time without having to figure it out like we did for this first one. So we're going to do this one more time for the oiling ring. We're going to measure the minimum clearance on the oil ring on the bottom, the 3rd ring. And as long as that's been completed and everything is safe, we're just going to repeat the process 7 more times and move on with the final part of the bottom end insulation. Well, it's been a long and arduous day so far, but we are coming to a close here on the bottom end assembly, and we are at the final assembly stage with just a few steps left remaining. So we've gone ahead and removed the rod end caps from the rod and piston assembly, and we've done that ahead of the fit up of the piston and rings to each individual piston. Once we're done fitting the rings themselves to the piston, we're going to be working to install them into the bore. We're going to start with 1 cylinder, and we're going to do the plastic gauge technique one more time on the rod bearing to ensure that the clearance there is adequate as well. We've already best matched the pistons to the individual bore based on their overall diameter, and we've set all the ring gap clearances to specification. So without further ado, we're going to go ahead and get rings mounted up to this piston, drive it in with our special tools, which we'll show you in a second, and get going on the clearance of the rod bearing check here on the bottom. All right, so let's start with the oil control ring, which is that corrugated ring on the bottom on the 3rd layer of the piston. And so you lay in that corrugated piece here, that's the oil scraper ring, oil control ring, whatever you want to call it. And these are very, very small, fine diameter. And basically you lay it in, one on the top and one on the bottom. So we're going to start with the bottom here. Well, yeah, we're going to start with the top because that's where it landed. Let that work its way around there. All right. That looks good. Taking the second one here. Honestly, these are the absolute easiest ones to install. They've got a lot of flexibility. There's not a lot of room to mess this up, honestly. Just take your time, make sure you don't force anything on where it shouldn't. You can get a good idea of what that looks like there. You can see that there are the two rings sandwiching that corrugated metal ring in the middle there. We're just going to give it a quick spin, make sure nothing looks funky. It doesn't. Looks good to me. All right, and now from bottom to top, our second Napier ring. A couple different ways to do this. You can do it with a piston ring expander. You can also just take your time, feed that around gently, carefully, without scratching. Oops. Okay, there's number 2. Looks good. And the top ring, the compression ring, same method. Laying that in the groove carefully. There we go. So we've got our compression ring, our second ring, our Napier ring, and our oil control ring there on the bottom. And basically before we set this into the piston ring compressor, which is here, and I'll show you that in a second, we're going to make sure that the ring orientation is correct. Now this is something that a lot of people, get messed up or they don't pay attention to when they install it, and you can see there that the ring gaps can actually end up, if you're not careful, right next to each other. And what happens is even once they compress, compression can actually bypass through that gap there. So what we want to make sure that we do is we put them away from each other, and it's easy to do on the top and the bottom. You basically want to make a triangle. So you put the one compression ring at one angle, you put the second ring at another, and then you put the end gaps for those third bottom rings at a third angle. So basically, I don't know, not 180, it's 90 degrees out from one another. Not very good at math today. And once you've done that, this is an adjustable universal spring compressor here, piston spring compressor. These are kind of custom pistons, not a size I'm going to use often, so no need to buy the real deal. This works just fine. Basically, you put the piston in there with the rings all uncompressed. Tighten this up. Pretty snug. I've already oiled it pretty considerably to ensure slipperiness. All right. Flip that over. And now we've got our rod bearings. Now we're going to put them in dry. They are labeled upper and lower. Okay, make sure that's fit up nice and tight. Looks good to me. All right, we're again not putting any lubrication on yet because we are going to check the clearance on one of these at least to get started. So that's it. This thing is ready to go in. We're going to measure it, or otherwise we'll be lubricating that surface. I'm going to spray a dab of oil down here in the journal just to give it a little extra lubrication. And let's walk it over here along with our piston hammer to cylinder 1. So this is probably the hardest part, and there's 2 factors here that we want to be careful about. One is the orientation of the piston. That can actually be put in upside down, believe it or not. You want to take a look at the 2 sets of valve reliefs that are cut into this piston, and you'll note that if you look very closely, the top one is larger in diameter than the bottom, and that's because it's for the intake side. So on the intake side, it has a bigger valve in the cylinder head, so therefore a bigger relief. So that's going to be on the top because that's where the intake valve sits on this motor, just like many other motors out there. Except for the N63 engine, which is the turbo engine for BMW, and they call that the upside down engine because the intake is actually on the bottom. Fun fact. So carefully going to lower this in here. I like to get the skirt just slightly protruding out of the bottom of the installer so I can center it just like so. Gently tap the installer to make sure that that's flush with the bore, which it is. And we're going to start to gently hammer that down into place. Now there's going to be some resistance on this depending on how much lubrication that you use, but you're going to be really careful to make sure that a ring doesn't slip out, because if it does and you keep hammering it, it's going to be a bad day at the farm, as they say. Definitely don't want that, because it's hard to get singular ring sets for custom pistons, trust me. It's nice and easy. Looks like one of my, yep. So there you go, perfect example. Take a quick look there. That top ring slipped out on install. You can see that there, it had busted out of the piston compressor, not fully compressed, and as a result, if I tried to keep hitting this down with a hammer, it would likely bend that ring and we'd be in pretty big trouble. So let's take this back out and reset, and we'll give it another shot. Round two, here we go. Try it a little bit different this time. Again, just kind of hitting in a circular motion, nice and easy. Once you get past that first ring or two, again, making sure that that installer tool is sitting flush with the block. You'll feel as each one goes through, because of the resistance back on the hammer frees up a good bit. There we go. We're going to have to push that down. And that's going to catch the rod underneath. And you can see where it has landed there on the journal. All right, so we've gone ahead and put a little plastic gauge on the crankshaft journal here in place of where is going to go our rod end cap. I've got that rod bearing loaded in. Again, dry this time for measurement purposes. So we're going to go ahead and put that on there. Okay, hand tight. Joining torque 20 Newton meters. Okay, and then a total torque of 65 Newton meters. Obviously not entertaining Ash enough today. About 1 1/4 thousandths, pretty tight. Pretty common, I would say, to be on the tighter side with for these coated bearings. Normally the coating adds a little bit of thickness depending on the type. Sometimes the WPC treated style, the shop peened version of these B&W aftermarket rod bearings, are just a surface treatment. The calico coating here, I believe, is truly a coating. It's over the top of the factory size bearing, so that would make sense. I'm going to go ahead and put this one together, but I'm going to check another one or two down the line here just to make sure. And again, a lot of this is also from, and I know this is going to generate some comments, I'm sure, experience and feel. So I've been doing this long enough to know that if we put a rod on, we go to spin the motor and the piston over, I like to check each time that we get a fully installed assembly in. You can basically tell if something is screwing up or if it's too tight as we add each piston, into each cylinder, all the way up to 8, and if that resistance for any reason changes or gets significantly more difficult, at least we know we got to stop there and we have a problem. So that's probably the methodology we're going to go with here right now. Like I said, a little bit on the tight side, but with a coated bearing, to be expected, and we're going to continue on with what we got here. A little fastener lubricant on here. It's already had a little bit on it, not to be confused with the liquid moly assembly paste, two totally different things. They look very similar in color and texture, to be honest, but they are meant for totally different jobs. Basically, you're going to rotate it through all the way. Make sure there's no high spots. You can see how those rings really do scrape lubrication, oil, fuel off that cylinder wall. Everything feels good there. Spins beautifully. Pretty low resistance. So I'd say that's a win for this one. So let's move on to cylinder 2. For those of you who are still with us, I don't know if I'm still with us at this point, but for those of you who are still watching at home, here we are with the last cylinder to assemble and put into this S62 fully forged bottom end. So we're going to walk you through this last process one more time, a little bit of a different way. Put it in the block. We're going to get you out of here in just a jiffy. So we got this piston and rod assembly here. We're going to finish up with this upper bearing. Just a dab will do you on that LM48 insulation paste. Flipping over for the rings. Oil control ring first. Top, bottom, doesn't matter. Just make sure it's uniform. There's one. Going for the bottom here. Making sure we're all on the same page. No problems. Number 2. Working our way up from the bottom. Feed it around, nice and easy. A little scratchy. And okay. All right. Now that we've handled it, I'm gonna rinse it. Avoid contamination. Blow on it for good luck. The bottom bearing in. Line that groove up. Okay. Sure that's nice and clean as well. Just a dab will do you on the bottom. Sure it's all nice and lubed up there. Bearing is nice and centered. Take the hardware out real fast. Again, different type of paste here. Making sure that bolt head is nice and lubricated. All right. Looking good. Piston ring compressor coming down. Loosen that bad boy up. Again, a little decontamination, never hurt anybody. Slang some lubrication in there. All right, coming on down. Gonna be on this side. Over here. Big valves on the top. Very good. Let me play you the song of my people. Flipping it over. Guiding that rod in. Very good. Little schmutz bit there, excellent. Never have enough. Yeah, maybe too much. Not enough, same thing. Lining up our tangs on the bearing. Put that cap on there. All right. Promise we're not fast forwarding the video here on you. Just trying to get finished with this after a very long work day. So I hope you're keeping up. Besides, they rebuild top fuel motors in about an hour and a half anyway. And at this rate, we've been here for about 6. So initial torque, 20 Newton meters. 20 Newton meters. And now balance it out. 40. 40. 65. 65. Little paint mark for good measure. Flip it back around. And there you have it. A fully assembled, well, mostly fully assembled rotating assembly in this supercharged S62 engine. So, CP Carrillo, low compression, 10-to-1 pistons, arrow forged connecting rods, sleeve block from VAC. This thing should be ready to make all the jam, and I'm sure it will do just that. So with that being said, I hope you enjoyed. Please tune in next time as we finish the rest of the installation and assembly of this motor. And thanks for watching the Tie Speed YouTube channel. We'll see you next time.